When you think about it, all those classic images of space exploration, they really stick with you. The astronaut alone, planting the flag, the spacewalker tethered against, well, just vastness, right? It feels like for so long, the human presence has been, I don't know, like the central point of the whole story.
Yeah, totally. I mean, it's iconic for a reason, right? But things are changing, and fast. That picture, the traditional picture, it's quickly evolving. Artificial intelligence, robotics, it's not just in the background anymore. It's becoming the main event in space missions, taking on tasks we used to think like only humans could ever do.
And you hit the nail on the head. That's exactly what we're digging into today. Our listeners are smart. They want to understand this shift, like really understand. But nobody wants to wade through a ton of jargon, right? So think of this as your shortcut, like a cheat sheet to get up to speed with this whole AI revolution in space.
Exactly right. So in this deep dive, our mission, what we want to do is explore, just how capable these AI-powered robots are getting and all the amazing things they're doing in space. We're going to look at some really recent stuff, advancements, real-world examples from like 2024, 2025, to see what this all means for our future, out there among the stars.
Yeah, let's be real for a second. Sending humans into space, it's a huge undertaking, tons of risks involved. It's incredibly complex. So the idea that AI and robotics can step in and do some of the really tough and dangerous stuff, that's a game changer, no question. So let's unpack this a little. What are some of the biggest advancements in AI and robotics that are really making these autonomous space operations, actually possible, like right now?
Well, the thing is, it's not just one thing. The progress on both sides, the artificial intelligence side and the robotic engineering side, it's been incredible, especially when you think about the specific challenges of space, What we're seeing now is AI that lets these robots operate much more independently. They're not just following basic commands. They're processing information, making decisions on their own. Imagine a robot navigating around, a surprise boulder or adjusting course based on what its sensors are telling it. It's happening.
And we're not just talking theory here, right? We have real-world examples of this. Let's take the IM-2 mission from Intuitive Machines. What can we learn from that?
The IM-2 mission, with an Intuitive Machines Athena lander, that's a really solid example. One of the big goals is to investigate water ice, near the south pole of the moon.
Right.
And to do that, they've included something really cool, a robotic hopper.
A hopper. So instead of wheels, it hops.
Yeah, exactly. That's the thing. It hops. And it's designed that way for a reason, to get into these craters, the ones that are permanently shattered. These regions are incredibly cold, almost no light, and we think they're full of water ice, but they're super tricky for a regular lander to get to. But this hopper, its AI, lets it navigate all that difficult terrain autonomously, collect data, and get this, search for that water ice. And being able to get into places that were like off limits before, that's huge. It's not just about the water itself, it's about understanding what's really on the moon, its resources, its potential. It's like we're opening a treasure chest of scientific data that we just couldn't get to before.
That's mind-blowing. Sending a little robot explorer into some of the most extreme places on the moon. And it's not just small-scale stuff either, right? NASA is working with private companies on the Lunar Terrain Vehicle, or LTV, something much, much bigger.
Absolutely. You have to think big picture here. If we're talking about, a sustained presence on the moon, that's the goal.
Mm-hmm.
Then the LTV, it's key. It's a collaboration between NASA and these commercial partners. And what's amazing is it's built to withstand like anything the lunar environment can throw at it. We're talking intense temperature swings, scorching sun, frigid shadows. It's got to be tough.
Going from one extreme to the other constantly. So this LTV, it's not just a tough truck, it's smart too.
Exactly. AI is a huge part of it, particularly for autonomous navigation. This thing doesn't need someone on Earth controlling it all the time. Its AI can plan routes, identify obstacles, avoid them. Kind of like a self-driving car. But on the moon, dealing with different gravity, lighting, all while navigating that unique lunar terrain.
So this isn't just sci-fi fantasy, right? We're talking about real missions, real vehicles using advanced AI and robotics right now.
Okay, let's shift gears a little bit. These AI robots, where are they actually being used in space today? Because it's not just about planning for the future, right? Right. AI robots are already doing important work in ongoing missions.
Yeah.
Like doing tasks that would normally take up a ton of an astronaut's time and, let's be honest, come with a lot of risk. A great example, the Crew Interactive Mobile Companion, or CMON, up on the ISS.
CMON, yeah, I remember hearing about that, like the robot assistant up in space. But what does it actually do for the astronauts up there?
Well, CMON, it's basically an AI-powered assistant for the astronauts on the ISS. So it responds to voice commands, can give them information, guide them through procedures, and even, get this, offer a degree of emotional support. Being on the ISS, it's a long mission. It can be isolating, so having CMON there, it can really help with the psychological side of things.
Emotional support from a robot, that's pretty wild. It shows you just how unique and challenging being in space can be. But it's not all emotional support, right? Robots are doing some of the, I guess you could say, the heavy lifting, right? Literally.
You got it. Think about the robotic arms, like Dextra, also on the ISS. These things are super sophisticated. They can do all sorts of maintenance and repairs on the outside of the station.
So instead of an astronaut having to go through all the prep, get into the suit, and do a spacewalk, which is risky, Dextra can handle it all remotely.
Exactly. It really cuts down on the need for those EVAs, the spacewalks. EVAs are risky. They take a lot of time. They're physically demanding on the astronauts. Dextra and robots like it, they can work for longer stretches. They can get to tricky spots. So it's a huge plus for safety and efficiency when it comes to keeping the ISS in good shape.
So we've got these AI robots enabling us to explore the moon more deeply, doing tasks we couldn't before. And then we've got them up on the ISS, acting like essential assistants, keeping things running smoothly. It all begs the question, what does this mean for the future of spaceflight? This increasing reliance on robots, what are the bigger implications?
That's a crucial point. The way we think about humans and machines in space, it's changing. And the implications, they touch on a lot of things. First and foremost, safety. We talked about Dextra, right? Robots can go into dangerous environments, do the work, and keep the astronauts out of harm's way. Imagine exploring a place with high radiation or dealing with some critical equipment failure outside the spacecraft. It makes sense to send the robot, right?
Yeah, that makes a lot of sense. It's a fundamental change in how we think about risk in space. And what about the cost? Space missions are expensive, everyone knows that. What impact do AI robots have on that side of things?
Well, that's where the potential for savings comes in. The less we rely on having humans there for every single task, the less a mission is going to cost. Missions designed mainly for robots, they don't need all those complex life support systems, the emergency procedures, all the medical stuff that humans need. So all that money that would have gone to those things can now go towards science, maybe even launching more missions.
So more of the budget goes to the actual research and discovery rather than just keeping humans alive in a, hostile environment. That's a strong argument. And you mentioned efficiency earlier, too. How do AI robots contribute to that?
Well, think about it this way. Robots, they don't get tired, they don't need sleep. They can work nonstop, 24/7, and that means the mission can be a lot more productive. Continuously gathering data, running experiments, doing repetitive tasks, is just keep going, and that can really speed up scientific discovery.
Safer, potentially cheaper, more efficient. It sounds almost like robots are about to take over space exploration completely, but surely there's still a vital role for human astronauts, right?
Absolutely. AI is great at a lot of things, but there are certain capabilities that humans have that are irreplaceable. Adaptability, for one. When something totally unexpected happens, humans can think on their feet in a way that robots, at least for now, can't. And then there's complex problem solving, going beyond what's programmed in. And let's not forget the human element, that intuition, that curiosity. That's what drives exploration in the first place.
That human spark, right? To be creative, to make those leaps of understanding when something unexpected happens, that seems like a uniquely human trait. I can't imagine programming that into an AI. At least not yet.
Yeah, you get the idea. It's unlikely that robots are going to completely replace humans in space anytime soon. What's more likely is a partnership, a synergy between the two, combining their strengths.
So big picture, it sounds like we're at this really interesting point, a turning point in space exploration. The classic image of humans at the center is being changed by these incredibly capable AI robots.
Yeah, that's a really good way to put it. The way AI and robotics are being integrated, it's a fundamental shift, no question.
But the key is, it's not about one taking over the other. It's about finding the right balance, that sweet spot where we use the strengths of both human explorers and their increasingly capable AI robot partners.
I think that's exactly it. The goal is to make space exploration more capable, more resilient, more productive. And we do that by using both humans and robots strategically to hit our goals, to achieve what we set out to do.
So, looking ahead, as this partnership between humans and AI in space keeps evolving, I want to leave you with this thought. What new and incredible discoveries might we make because of this collaboration? How might this synergy, this human-robot partnership, change our understanding of our place in the universe? It's something to think about.
And it's worth thinking about the long-term implications too.
Yeah.
Because AI is advancing so rapidly, the big question is, what's the best way to divide the work? How do we best use humans and robots in the decades to come? And it's a question that's going to shape our future in space, that's for sure.